So fam, these are the video solutions for Unit 7 exam. I'm probably not going to spend too much time going through these problems. So if you need a little bit more guidance than what I'm offering here, please, as usual, feel free to come in and see me or email me any questions that you have. So for the multiple choice, I think that I'll just show you the answers. These are the answers in order. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, guys. Whenever they ask me about anything about power, I will often draw this little graphic. I also think about thing 1, thing 2, and I remember if it's a type 1, that means hypothesis 1 is true. If it's a type 2, that means hypothesis 2 is true. I'm just reading through these as I'm showing you my answers to see if there's anything that I feel like I need to discuss. Okay, on the free response, I think that lots of them are pretty straightforward. At least the first one is. First one just asks you to run a hypothesis test to see if there's convincing evidence that more than 67% of the authors support continuing the system. So one good thing about this is that they just tell you that you're doing a hypothesis test for more than, so that makes your alternative a little bit easier to determine. The one thing that you want to be careful about when you go through and word your answers is that you are using appropriate context. So we're talking about authors that support continuing the existing system. Make sure that you always label your tests. You must always label, is it a one sample Z interval? Is it a one sample T test? Is it a one sampled paired test? For the last, I think, 2 units, it's really important that you label what procedure that you're doing. Because this is a proportion, you were finding a Z-score, and I believe that what I have here is enough for full credit. But if you have time, you should always draw the associated picture. And one thing that I was seeing that concerned me when I was grading your exams is if you're going to put the true proportion in, make sure that you put it right at the center. Some of you guys were labeling it over here, and it was very unclear what you were trying to label. Make sure that if you're saying, okay, the true proportion is claimed to be in the center at 0.67, that you are actually labeling it at the center. Then this is just saying the p-value that you found is the area under the standard normal curve. That statement should make sense to you, especially going in reviewing for your actual exam. So if that statement does not make sense to you, you need to make sure that you get that figured out. I'm going to say that one more time. Your p-value is the area under the curve associated with the z-score that you found. So it's just telling you what is the chance that you'll get this sample value if the null is true. So the chances that you would get a sample value of 69% if the true proportion is 67% is about 0.336. So it is totally plausible. And then I actually just talking about that kind of interpreted the p-value. So remember, p-value is always if the null is true, what is the probability we would get the sample value that we got or a sample more extreme? So in 67% of the recent, this reminds me of the other thing I was going to tell you. The sample and the population that you are investigating is recent authors that support the system. Please be very careful about knowing that that's who you're looking at. Recent authors. Not all authors of this publication, recent authors. So if 67% of recent authors support the system, there is a 0.3336 probability of getting a sample proportion of 69 or higher just by chance in a random sample of 104 recent authors. So the other thing that I don't think that I discussed quite as much as I should have is that end part that says in a random sample of 104 recent authors. Now, I'm not sure if that's enough to bump you from an E to a P, but if you can add it in, if you can remember it, awesome. If you can't, you will probably be just fine. Okay, number 12. I think that these ones were the hardest ones for you. If what you're seeing here doesn't make sense, make sure that you ask me, because remember, especially now that the test is only a couple of weeks away, it is way more important that you are doing these corrections for the understanding than that you're doing them for the points. The points are not going to help you earn your college credit. The understanding is. So interpret power. Power is our ability to recognize that the null is not true. So they're saying, if the true proportion of seeds is really 75%, the claimed value is 80, but if it is truly 75%, there is a 0.69 probability that we will reject the null in favor of the alternative. So they're saying if the true proportion is 75% instead of 80, the power is the probability we will correctly reject. Notice you do not use the null hypothesis anywhere in this explanation. So they're saying if this other value is true, notice that it's not a p-hat and it's not the null value. They're saying if the true proportion is 75%, if the true proportion is 0.75, there's a 69% chance that we will correctly reject. What is 0.69? It's the power. The power is your ability to recognize there is a difference and correctly reject. 2, describe 2 ways the company can increase the power. Now, we talked about this when we went over your 2017 released exam, but this is a great idea to reinforce it. So 1, increase your sample size. Now, why is this an advantage? In the notes, I just said it's more information about the population. The better answer is increasing sample size decreases your standard error. Sorry, I'm trying to find a pen that works. What are the chances that none of these work? A friend recently gave those to me. None of them work. Okay, so decreases the standard error, which remember, standard error is your SX over root N. Well, really, I should just highlight that your standard error has root N in the bottom, whether it's a proportion or a mean. So in this case, it's a proportion, but that just means what's in the top is P sub 0, 1 minus P sub 0. So if you increase sample size, that means that you decrease standard error because sample size is in the bottom. So if you make your denominator bigger, you make the overall value lower. Well, when you decrease standard error, you increase this true? Pause. I need to think about that for 1 second. Okay, I found it. So I just needed to make sure that I was saying this correctly. When you decrease your standard error, because it's in the denominator for your test statistic, when you make this smaller, then the overall test statistic increases. So that's why sample size, increasing sample size, gives you more power. So if we increase sample size, we decrease standard error, which increases Z or T. In the very least, you should memorize this. Increased sample size decreases standard error, which increases Z or T. This is the formula for standard error. Z or T is that fraction that's your statistic. So this is always found doing statistic, subtract parameter, all over standard error. That's a lot to keep track of. So in the very least, memorize increase N decreases standard error, increases Z or T, depending on whether or not you're doing a proportion or a mean. I'm going to write that in too. Okay, then the last one, use the confidence interval to determine whether we would reject or fail to reject the null. So at alpha equals 5%, where did I get 5%? Because your confidence interval is 95%. So at alpha equals 5%, we fail to reject the null because 80% is in the confidence interval. So it is a plausible value for P. We do not have convincing evidence that the germination rate of the seeds was changed by the chemical spray. You really can't deviate too much from this. So you have to have all the things. At alpha is 5, we fail to reject because 80% is in the interval. So it is a plausible value. We don't have convincing evidence. Okay, I feel okay about that one. I'm just going to look at that one for 1 more second. Sorry. Then our last one, they actually give you a data set, and you have to determine whether the fertilizer had a positive impact on the weight of the corn ears. So I do, when they give me the data set, I run all of the stats first. So over here you can see my average, standard deviation, degrees of freedom, my box plot appropriately labeled. So you need to make sure that you have it scaled and labeled. In our Unit 1 overview, I just filmed that, and I was going over how whenever you make any graph, whether it's for quantitative data or categorical data, you have to make sure that you always label and scale your graph. So on my box plot, I have it scaled, I have it labeled, I have the graph, and then up here I'm saying, okay, this has some skew but no outlier, so that's good. I did graph the NPP in my calculator and made a note here that it was approximately linear. So I did all of this before I even started the problem. You don't have to do that, but it's easier for me. This is my statement of the hypotheses. If the fertilizer had a positive impact, that means that your corn is going to weigh more. So that's how I knew to do a greater than. Positive impact means more corn, weighs more. Make sure that you clearly define your mu. Then just like previously, make sure that you are labeling what test you are doing. As we've gone through and done the mini exams and the practice exams, it's becoming clear to me that if you don't name the procedure you're doing, you don't get full credit. So be careful on that. Here are my 3 conditions. Random sample. My sample size is too low, but I graphed the box plot. See how I said graphed above and the NPP, not graphed above, but indicate we can use T procedures. I should say not graphed above. If I just say not graphed, then how can I say that? So I don't have to say this again, no outliers and some skew, because I'm saying I graphed it above. Essentially, I'm saying go and see what I wrote on my graphs. 10% condition, make sure that you checked all 3. Some of you guys get a little bit crazy when you're checking conditions and you just write it all over the place. Make sure that you are pretty organized in your work. It shouldn't be this way, but I have a feeling that if you have messy work, your AP grader is less likely to give you like more points. Like not necessarily more points, but I know sometimes when your guys' work is really messy, I'm less likely to give you partial credit. So make sure if it's one little thing you can do is keep your work organized to keep your grader on your side. Organize your work because it'll be worth it. I used my calculator and got a T critical of 1.836. From the calculator, my p-value was about 5%. And then my final statement. Since my p-value is less than, and it's just barely less than, but it is less than your alpha, you reject the null. We have convincing evidence that the mean weight of all corns is more than 8 ounces. Sorry, I was making sure that my conclusion was correct. Okay, so that's quite a bit of feedback on the free response. On the multiple choice, not so much, so if you need a little bit more guidance on those, just make sure that you let me know. Sorry, I'm trying to zoom out. My document viewer's like busted. Okay, so free response, multiple choice. As usual, if you guys have questions, let me know. Email me, ask me in class. Okay, I think that's it. Love you guys.